I used to record, but some instances, my problem is sufficient data. If it is not there, I cannot upload one recording. Some children simply say, sir, send the recording. One recording is 200 MB data. Okay. So today, in the lesson, we are going to speak about, what is it? Couple of forces. What is the heading? Couple of forces. Okay. So, couple of forces has three things. If three conditions are fulfilled, then it will be a couple of forces. What are the three things you are given? There should be how many? Okay, two forces in three conditions. What are the three conditions? Number one,
Equal forces.
number two,
Opposite forces.
number three.
Parallel forces.
If these three conditions are fulfilled, they will be what kind of forces? Couple of forces. Right? Here, let us draw a diagram. Here there is an object. In this object, a couple of forces are going to function. Here, if one force is working in this direction, an equal force should work in the opposite direction in this manner. Understood? Are you clear? If this is 50 Newton, this force also should be how much?
50 Newton.
50 Newton. So see, two equal forces. Are the two forces in opposite direction?
Yes, sir.
And they are parallel to each other. If these three conditions are fulfilled, a couple of forces will be created. When a couple is created, it will develop a turning effect. What kind of effect is created?
Turning effect.
A turning effect is created. So, in our day-to-day life, in many places, we have couple of forces working. First of all, mark this one down. We will further discuss. When you receive the hello message, do you have a speaker mark in your message? My children, do you get a speaker mark?
Yes, sir.
If the speaker mark is coming, you have to understand it is coming through the broadcast.
No, sir.
No? You don't see the speaker mark? If not there, okay, leave it. Have you received the sulfur short questions?
Yes, sir.
Yes, sir.
Complete it sooner. Inshallah,
Completed, sir.
tomorrow night around the scheme will come. That is one side going on. Learning is a process. That's what I'm trying. So think of a week. In this week, except the Saturday class, because of me, how many times you interacted with science? Did you understand my question?
Yes, sir.
Except Saturday class, okay, because of me, how many times you interacted with, what is it, science in this week? Can you send me an answer in the individual answers? Hope you can understand the question. Except Saturday class, from last Saturday to this Saturday, how many times you interacted, you went, noticed notes, doing a question, something you do because of this guided program. That's what I'm asking. Because of this guided program, can be a Shyamali paper, can be an MCQ paper, okay, can be a video. Because of something, except Saturday class, within a week, how many times you interacted with the science subject because of this program? And remember that interaction is the success of that program. Understood? That interaction is the success of that program. If that interaction is not there, the program will not succeed. So, the program, okay, you don't understand, no, suddenly comes Shyamali papers, right? You need Shyamali paper 4 to Shyamali paper 5, there's a gap, but that gap, do you feel? My children, do you feel that gap? We did one paper, then lots of time, no paper, oh, we didn't get anything. Now again, Shyamali paper, next paper has come. Is that way a feeling is there to you?
No, sir.
No. No. Why? Continuous interaction is there. It's a master work. It's not easy. It's not easy to maintain that one. Okay, okay. Have you copied it?
Yes, sir.
Good, good.
Yes, sir. Copy.
Now, my children, it is a turning effect, no? Correct? It is a turning effect. There's a turning process. So, turning effect is there, mean moment is there. Understood?
Yes, sir.
How to calculate the moment? How to calculate the moment? Force multiplied by
Perpendicular distance.
perpendicular distance between the
Lines of action of the two
lines
forces.
of actions of the
Two forces.
two forces. Clear?
Yes, sir.
Right. There are many examples in our day-to-day life. One is this: when you are opening a tap in this way, here you apply a force. Here you apply another force. So do you notice the couple of forces?
Yes, sir.
Mark the two arrows in the diagram.
Done, sir.
Good. Similarly, when we are turning a screw, screwing or unscrewing, when you are turning, okay, two forces, okay, like this, you are turning it. Understood? Two forces. Unscrewing, okay, screwing, okay. If you keep a screwdriver and turn and fix, there you are applying a couple. Clear?
Yes, sir.
Yes, sir.
Good. Thirdly, steering of the vehicle. Here, if you are turning to this side, if you apply a force to this side, then this hand will apply a force in the opposite direction. Correct?
Sir.
Mark the arrows. Mark the arrows. Right. So, completing that one, we are coming to the heading called, what is it? Equilibrium of forces. You studied resultant force, correct?
Yes, sir.
Yes, sir.
Right. Simple idea for equilibrium is if the resultant force is zero, then will there be a change? Will there be a movement?
No, sir.
No. In that case, it is called equilibrium. Understood?
Yes, sir.
Right. When two forces to be in equilibrium, how many forces?
Forces.
Two forces to be in equilibrium, three conditions should be fulfilled. One condition is
Equaling magnitude.
forces should be equal in magnitude. The two forces should be
Acting in opposite direction.
opposite in direction, and the two forces should be in the
Same line of action.
same line of action. If any one of these condition is not fulfilled, it will not be in
Equilibrium.
equilibrium. Okay, to show that one, we will draw a diagram here. Here there is an object. On this object, okay, in this direction, if there is, okay, 100 Newton force works, say. Another 100 Newton force should work in the, say, okay, opposite direction. I am drawing it like this to catch the point. Okay, this is also, what is it? 100 Newton. Now see, if you draw a connecting line between these two, if you draw a connecting line between these two, it will be a single line. Understood?
Yes, sir.
That is why I say same line of action. Now see, are the two magnitudes equal?
Yes, sir.
Are the two directions opposite?
Yes, sir.
Do they have the same line of action?
Yes, sir.
Yes, sir.
Then there is
Equilibrium of
equilibrium. If equilibrium is there, two things are there. What is it?
Resultant force should be zero.
Resultant force is zero. If there is equilibrium, no any
Changes will occur.
change occurs. No any, what is it? Change occurs. Clear?
Yes, sir.
Could you please complete it down? Remember, if any one of these condition is missed, then equilibrium will not stay. Understood?
Yes, sir.
If magnitudes are not equal, no equilibrium. If the directions are not opposite, no equilibrium. If same line of action is not there, no equilibrium. At least one condition is overruled, no equilibrium.
Completed, sir.
Have everyone completed it?
No, sir. No, sir. Done, sir.
Have everyone completed it?
Yes, sir.
Have everyone completed it?
Yes, sir.
Yes,
Good.
sir.
Good. Now, instances where this kind of equilibrium exists in our life. Say, from the, now what is what the first thing say? An object resting on a surface under gravity. Here say, this is a table. On this table, say there is a book on the table. Okay. Now on this book, two forces are working. One force is working upward. Another force is working how?
Downward.
Downward. The upward force working. Okay, first The downward force working is called, what is it?
Wait.
Weight. The upward force working is called normal, what is it?
Reaction.
Reaction. If you take weight and normal reaction are equal in value, opposite in direction, staying on the same
Line of action.
line of action. Isn't it enough to tell they are in equilibrium?
Enough, sir.
Enough. So this is the diagram you have to complete under that point.
Done, sir.
Done, sir.
Okay, completed.
Yes, sir.
Yes.
Right. Coming to the second one, any object hanging, any object, what is it?
Hanging.
Hanging. Now, from the roof, okay, using a thread, using a, what is it? Thread.
Red.
An object is hanging, say, right? In this one, there will be two forces working. One force is working downwards. Another force would be working,
Upwards.
what's it?
Upwards.
Upwards. The downward moving force is, what's it?
Weight.
Weight. The upward one is actually a reaction. We call it by the name
Tension.
tension. So if you take tension and weight, they are equal, they are opposite,
Line of action.
and they are in the same line of action. Clear?
Yes, sir.
Okay, you can mark it down.
Done, sir.
Completed it?
Yes, sir.
Now we are coming to the, what's it? Equilibrium of how many forces? Three forces. Okay, three forces. Three, what kind of forces? Coplanar parallel forces. What is the condition? What is the condition? It should be coplanar, acting on the same plane. And what kind of forces?
Parallel forces.
Parallel forces. Here, two of the forces. Now, altogether, how many forces are there?
Three.
Three forces. In the three forces, two of the forces will be in one direction. The other one will be in the opposite direction. Understood?
Yes, sir.
Two of the forces will be in one direction and the next one will be in the
Opposite direction.
opposite direction. Let me further explain you that. Here, say there is an object. Here, two forces. Say one is 10 Newton, other one is, what is it?
15 Newton.
15 Newton. In that case, the third force should be in the, what is it?
Opposite direction.
Opposite direction. Its value should be the total of these two. Then how much should come here?
25 Newton.
25 Newton. Clear?
Yes,
Yes.
sir.
Suppose if the two forces are working this way, say so, this is 20 Newton C, this is 30 Newton C. Third force, how should it come?
Downward direction.
Opposite direction.
In the opposite direction, and its value should be
50 Newton.
50 Newton. Clear?
Yes, sir.
Yes, sir.
Right? So the total of these two should be equal to this. Actually, the meaning here is, actual meaning here is, for 10 Newton and what is it? 15 Newton, you studied in the last class resultant force, right?
Yes, sir.
How to find the resultant force of two parallel forces in the same direction? How to find the resultant force of two parallel forces in the same direction?
Get the
Hmm? How to find?
heading.
Adding. 10 Newton and 15 Newton will be
25 Newton.
25 Newton. That 25 Newton will be here. Understood?
Yes, sir.
This 25 Newton and this 25 Newton are equal. This 25 Newton and this 25 Newton are opposite. This 25 Newton and this 25 Newton are in the
Line of action.
same line of action. So here 20 Newton, 30 Newton,
50
how
Newton.
it will be the resultant mean? Resultant will be like this. How many Newton?
50 Newton.
Now this 50 Newton and this 50 Newton are
Equal.
equal. They are
Opposite.
opposite. They are
Same line
occurring
of
in
action.
the same line of action. So the condition here is, okay, resultant of two forces, okay, should be one condition equal, second condition opposite, third condition in same line of action. If these conditions are there, they will be equal. Are you clear? So they will be in equilibrium. Check your tune. Have I written this part?
Yes, sir.
Sir.
Yes, so you don't need to write that. The only thing it is, draw these two diagrams and complete the work.
Done, sir.
No, sir.
No, sir.
Have you completed it?
Yes, sir.
Good. Now, what is the next heading for you? What are the places we will notice equilibrium of three coplanar forces? Correct? What is the
Yes, sir.
what is the first thing you are told?
Cloth hanging on a cloth linear.
Cloth hanging on a cloth line. Here, this is a cloth line. Okay, fixed to the what's it, earth. Right? On this cloth line, there is a cloth hanging this way. Now, this cloth's weight will be working in what direction?
Downward direction.
Downward direction. In these poles, there will be two reactions. I will tell this is reaction 1, this is reaction 2. So at equilibrium, if you add reaction 1 and reaction 2, what will come?
Weight.
The weight will come. Understood?
Yes, sir.
Is the screen clear?
Yes, sir.
Okay. That's all, Pudha. You can mark it down. Have you completed it?
No, sir.
No, sir.
Okay, okay. Inshallah, today you will get the unit number 10 tute. It will come to you personally. Understood? It will come to you personally through the broadcast.
Okay, done, sir.
Have everyone completed it? Have everyone completed it?
Yes, sir.
Yes, sir. What is the second example given to you? Read the second example.
Hanging
Read
a
the second
tube,
example. What is
hanging
it?
a tube fluorescent lamp from roof.
Suddenly, right. Here, you know tube light, correct?
Yes, sir.
That is fluorescent tube. Here there is a tube light. Looking at some human being also, people used to call, what's it?
Tube light.
Tube light. Because tube light will take a little time to switch on. So, from the roof, tied in two places, here, tube light is hanged in this manner. Okay. In this manner. So here the fluorescent lamp, here the two tying threads are there. Here, the tube lights weight will be working in the downward direction. Here there will be two
Tension.
tensions. This is tension 1. Here there will be tension 2.
Two.
So at equilibrium, okay, remember when it is hanging, it is in equilibrium. If it is not in equilibrium, it will either come down or go up. Understood?
Yes, sir.
So it is in equilibrium. At equilibrium, the weight is equal to tension 1 plus
Tension 2.
tension 2. Clear?
Clear, sir.
Right. So you can mark it down. After you complete that, we will go to the next.
Done, sir.
Have you completed it?
Yes, sir.
Right. So similarly, I am not going to ask you to draw the next one. Say there is a swing. You know swing, correct? On
Yes,
chill, right? There's a swing, right? One person is seated here. I am not good in drawing a human. Okay. So there's a person staying here. His body weight is going to work downward, correct?
Yes, sir.
There are two tension forces
Tensions.
upward. So the total of these two will be equal
Weight.
to the weight. Are you clear?
Yes, sir. Clear.
Thereafter, we are coming to the next heading. What is the heading? Equilibrium of a body under three coplanar forces that are not read it, that are not
parallel and working on a single point.
right. This is the general appearance of those three forces. Okay, this is the single point. the forces will be working in the shape of letter Y. Understood?
Yes, sir.
Yes, sir.
This is the appearance. Here, if I take this one as F1, if I take this one as F2, and take this one as, what is it?
F3.
For F1 and F2, there will be a resultant, right?
Yes, sir.
Sir.
That resultant is like this. Understood?
Yes.
So what is this R?
Resultant.
R is the resultant of whom and whom?
F1 and
F1 and F2.
Resultant of F1
and F2.
and
F2.
F2. Clear?
Yes, sir.
This R is equal to, what is it?
F3.
F3. This R is opposite to
F3.
F3. This R and F3
Same line.
share the
Same line.
same line of
Action.
Action.
understood?
Yes, sir.
Therefore, okay, if these three are fulfilled, okay, who is achieved?
Equilibrium.
Equilibrium.
Equilibrium attained. Understood?
Yes, sir.
You can draw them down and under in page number 16 in the bottom, you can mark these details. Have you completed it?
No, sir.
Done, sir.
Sir, no.
உங்களோட போனுக்கு ஒரு டியூட் அனுப்பியிருப்பேன், அதை எனக்கு திருப்பி அனுப்பிவிடுங்க.
Completed, sir.
Completed?
Yes, sir.
Yes, sir.
Good. So, here we are coming for a photo frame. What is it?
Photo frame.
A photo frame. In a photo frame at homes, nowadays this kind of a culture is very rare. In those days, we will see so many photo frames hanging in the walls of the houses. Okay, school, okay, though the marriage photos, everything. This is a photo frame hanging on a nail here through threads in this manner. Okay. Here, in this direction, who is working?
The weight of the photo.
The weight of the frame is working. Here there will be a tension force. What is it? T1. Here there will be a
T2.
tension force T2. Now, what I am going to do is, now this is a vector quantity, no? T1 is like this mean, T1 is working this direction, correct? T1, T2,
Yes, sir.
sorry,
Yes, sir.
T2. T1 is working this direction. T1 is working this direction. W is working this direction. Understood?
Yes, sir.
Yes, sir.
Now see, can you see the Y shape?
Yes, sir.
Yes. So T1, T2, sorry, T1, T2 and W are in, what is it?
Equilibrium.
Equilibrium. In the two forces, I used to tell you here before also, the resultant of T1 and T2, the resultant of T1 and T2. Okay, what is this force?
Resultant force.
Resultant of
T1 and T2.
T1 and
T1
T2.
and T2 is equal to whom?
Weight.
The weight. But you know, resultant of T1 and T2 is not the total of T1 and T2. Understood?
Yes, sir.
In resultant force also I told you that. Resultant of T1 and T2 is not the total of T1 and T2. Can you remember? I told a longer equation. F1 square plus F2 square. One person asked me. Who asked it last class? Sir, what is that equation?
Me, sir.
Then I told you no. F1 square plus F2 square plus 2 F1 F2 cos theta.
Yes, sir.
Okay, that means in the past paper, they have pointed like this. Weight is equal to T1 plus T2. Will you take this statement as a correct statement?
No, sir.
No, it is a, what is it?
Wrong.
No, sir.
Wrong statement. Clear?
Yes, sir.
The total of these two will not be equal to
Weight.
weight. Resultant of T1 and T2 will be equal to weight. This is correct statement. Which one?
Resultant of T1 and T2 equals weight.
Equal to weight is the correct statement. But if they say weight is equal to T1 plus T2,
Wrong.
it's a wrong statement. So this is the last portion. So please complete it down.
Okay, sir.
Completed, sir.
Completed.
No, sir.
Have everyone completed it?
No, sir.
Yes, sir.
Right. Thing is, today, inshallah, immediately, I will send you the unit number. What is it? 10 tubes. Unit number 9 over, 11 over, 12 over. But we have to complete the unit number 10. It will be coming to you personally. The tubes will be coming to you. What is it?
Personally.
Personally. Okay. So if you have completed this, today we are ending the class at this place because the lesson is over. Inshallah, freshly on coming Saturday, we will be starting the unit number. What's it? 10. Clear?
Yes, sir.
Yes,
Clear.
sir.
Yes, sir.
Good. Good. So, bye. Assalamu alaikum.
Thank you.
Thank you,
Jazakallah.
Thank
sir.
you, sir. Have a nice day.
Assalamualaikum salam.